Alright, before debugging what's wrong with our spine, we need to get ready to have a more modular component for the entire torso rig that we've been working on. So I'm going to do that first, and then we can more easily try to see what's going on with it. So I'm going to hide the geometry so we can focus just on our torso rig. And what I'm going to do is I'm going to create a group locator. And I'm going to move it over to the base of the spine. So let's take the group locator, move it over here. And we're going to call this group torso. All right. I could specify that it's at the center of the character, but well, unless you have more torsos, then I guess it's pretty much it's understood. And now what I'm going to do is I am going to hold on a second. Yeah, everything's okay. Let's go into setup mode. Let's do all this in setup mode because this is going to be important. Let's move everything in the rig into the group torso group. Okay? Everything except the weight containers. Alright. So now that we have everything under a single hierarchy, I'm going to create a temporary locator that I'm going to use to represent the character as an entire asset. And or actually we could leave it as a permanent locator and start assembling our rig. Let's call it character ace. Okay, this is going to be our character locator, and let's change its display, and it's going to be a not a cylinder, a circle facing up in Y. That's going to represent our character. Okay, we're going to package the entire rig, every piece under this. So for now I'm not going to use it for anything in particular right now, but later on we're going to be using it to test some of the stuff that we've been doing so far. And for now I'm going to parent the group torso under this locator. So let's do that. Let's get our setup mode. Everything is still okay. So we're gonna look at a few things that we need to do to our rig to fix some of the issues we're having so far. Okay, so let's take a look at what's going on with that funky spinning that we see. If you recall, when we moved the group object, you can see the torso sort of turning, and that's basically also the same problem that we noticed when we would twist our torso. Well, not twist it, but rotate the controls, and you see it twisting like that, and that's really odd. Well, what's happening is our joints are writing the curve using a path constraint, and the path constraint, when you constrain an object to a path so that the software can keep it aligned to the path, it needs to know which way would be, let's say, up, so that the object can be pointed that way. When you specify that, then the software can keep the object always aligned to that up, and that's what the up vector does. So in this case, our up vector is set to the y-axis. If we go ahead, I'm gonna make this slightly bigger, and we select all of our constraints, and we set the up vector to the z-axis, then when you rotate the controls, you don't get any more of that twisting. And we can move the torso control, and we don't have that problem anymore. However, this is not really the solution to our problem. The reason is, if I take, let's say, our character main control, and I rotate the character to face a different direction, as you can see, the torso is not rotating with it. And that's because we've told the system that we are going to be using the z-axis as our up axis. So now you can see that it's pointing in the z-axis in world space. So it's aligned to that direction. So let's go back to our path constraint. We can try to use a local up vector, but that still doesn't give us anything we can use. So what we're going to do is we're going to create our own up vector object that is going to be part of the rig, so it can move with it, and then the torso will respond. So let's go ahead and create a new locator, and we're going to call this locator UPV for up vector center spine curve. That's going to be the, well, actually no, not spine curve, because it's not the curve that is going to be the up vector for spine joints. There you go. And we're going to make this part of the torso group so that it will stay with it. And we're going to match its position to the base of the spine rig. And then we're going to move it forward so that there's a certain distance between the torso rig and this locator. And let's make it smaller. There you go. So now that we have our locator created, we can proceed and assign it as an up vector for the constraints. So I'm going to select the constraints, shift select the locator, and if I come to the properties for the constraints, I think I need to do this in the opposite order. The locator, yeah, modifiers, there he is. We can go to the assign up vector button, and as you can see, now all the objects that have these constraints are connected somehow to the locator. What they're doing is they're actually pointing towards it. Okay, so if I move my locator, you can see our torso turning. And now what's happening is we can take our main character control and rotate around it, and because the locator is part of the rig, our torso rotates with it. And this also solves the problem of the twisting joints. I need to get out of setup mode, of course. So there you go. We can twist our controls into a pose and everything is okay. So that's basically how this setup works. So we've solved that problem. We're not done yet. There's one more thing we need to check. But before we move on, let's take care of a few details. First, let's make sure all of our controls are zeroed. So let's zero these guys' position. This guy is fine. This guy is fine. This guy, zero its position. We're also going to do the same for our locator over here. And I think the rest is fine. We can zero out our group. And we're looking good. And one other thing that I'm going to do, since I just remembered that I wanted to do this, is take the opportunity to make sure I can pick walk through my controls on the torso, since they don't belong to the same hierarchy. So what I want to do is, let's find where this control is. Here he is, FK spine lower. I want to be able to pick walk to it from this control. So if I pick walk down, we should go to Control C, FK spine lower. Let's do that again. Control C, FK spine lower. Hold on, I passed it. Control C, FK spine lower. There we go. So now we can pick walk down to those controls. It looks like I set it maybe somewhere else. Let's see where I set it. I'm gonna set this to none to redo it again. So let's select, I make sure I have the right thing selected. This is the Control C hips, okay. Pick walk down, Control C FK spine lower. Here it is. Good. Now, and from here I want to pick walk down to the shoulders control. Oh, not the constraint, but the actual control. Control C shoulders. There you go. Perfect. Now I can traverse this virtual hierarchy with my hotkeys. Alright, so we're done with this. In the next video we're going to take a look at one more thing that we need to check before saying we're done with our torso rig. So see you there. Okay, so we're doing fine. Let's just check one additional thing when it comes to dealing with our character. Let's say that I take the character control and we're going to position him somewhere else, and I can see something odd going on here at the base of the character. He's kind of losing weight over there, and we're gonna look into that. So this is odd, because if we select our spline, our curve, and we select its vert, you will see that if I select one of the weight containers, let's say the lower spine, and go into the adjust weights tool, the weights have been set correctly. Okay, so that would be kind of strange that this would be happening if the weights are okay. Moreover, if I select again our character control and I scale it up, oof, we see something really odd happening with our rig. Well, there are several things happening in here, and mostly what's going on is our rig has not taken into account changes in scale coming up from the hierarchy. So right now what's going on is that the weighting system used by the deformers we're using is not compensating for these changes in scale. So we're getting like extra weighted deformations happening over there. And there is one easy way to fix this, actually. The thing is, it might not be very obvious when you face it the first time what the problem is, but the fix is actually quite simple. Let's go back into setup mode. Let's look at the deformers that we're using for our rig. Here we have weight containers and our transform deformers. So what we need to do is take these transform deformers and normalize them. So let's create a normalizing folder and move them over there. So now these deformers are adding all their weights always to 1. Obviously, for this to work, we need to make sure that the weights of our curve are properly set to go from most weighted to an unweighted sort of fall off, depending on which weight container we're using. So for example, if I use the lower spine container and I select the vertices, let's go into wireframe just to make things easier to see, and I check my weights, you will see that the weights right now are all of them at 100%. And if I use my upper container, they're also at 100%. So right now the normalizing it's gonna work, but it's probably not gonna do what I would expect it to. And what I want to happen is when I move the as we did it before, when I move or do something to the shoulder control, I want to see things decaying over this area. And because we have normalized the deformers, now we have to change the weight for each container. So this is what we're going to do. I'm going to start with the upper spine container. So the first vert is fine. It has to be 100%. Okay, so this one is okay. Now I'm going to move down towards the hips, and I'm going to be decreasing the weight of this container for each vertex. Okay. How am I going to do that? Well, I need to use the values that we've already used over here. These are like my joint indices. They were the percentage along the path that they were using. Well, now we're going to use this as a percentage for weight for each joint. So I'm going to start at 100% for the topmost vert for this container, then go down to 83%, 67, 50, 33, 17, and 0% for the last vert at the bottom. So let's do that. The first vert, I can leave it alone. It's already at 100%. Let's take the second one and adjust its weights. I'm going to bring it down to 83%. Then select the next one and bring it down to 67. Usually when you're operating on meshes, it's easier to use a set value brush, but because it's a brush, it doesn't work with curves. So we need to use the adjust weights tool. Where was I? The last one was 67, so this guy needs to be 50. Fortunately, this tool always snaps at whole increments, so it's easier to use when you're there, but sometimes you need to be careful with your mouse movements when you're approaching the value you need. 33%, 17, and lastly 0%. There we are. So now we're done with this container. If I select all the verts and check their weights, we can see 100, 83, 67, 50, 33, 17, and 0. We're good. Let's now do the same for the lower spine. Obviously going in the opposite direction. I want to start at 100% at the bottom and go up the spine towards 0%. So let's select the second vert and adjust its weight down to 83%. Now to 67. This guy needs to be 50. This one needs to be 33. This one needs to be 17. And the last one needs to be 0. Okay, now we're done. Let's go back to item mode and see what this gives us. Let's get out of setup mode. Select our control, move it, and now we don't see the problem we were seeing before, that little offset that we had. Now everything is working properly. So we've solved that problem. If we scale our rig, we still see something interesting happening in there, which is actually not bad, but let's try something else. Let me undo the scale change, and I'm gonna make sure that the non-stretchy IK is on. Let's scale again, and wow, that's interesting. As you can see, the rig is scaling, but the torso is not scaling with it. It's staying in place. So what's up with that? Well, we're gonna find out in the next video. Okay, so let's take a look at what's going on with our spine. As you can see, when we're using the non-stretchy system, the spine is not really reaching the top, and in theory it should, because, well, we're scaling the entire character. If I set this to stretch, then it's okay, it's reaching. but it looks like the lengths are not being calculated correctly. Well, actually they are, but they are calculated correctly for a spine that is 100% scaled. It's whose scale is 100%. And in this case, our entire rig is inheriting the scale coming from this object, which is now scaled to something else at 100%. So we need to get our rig to take that into account. And that's actually not that difficult to do. So we need to bring the scale of this guy into the rig somehow. So let's start by adding him. Let's add the selected item. And I'm going to leave it around here for now. And let's bring in one of his scale channels. We're always going to be uniformly scaling the character, so it doesn't really matter which one. We just need one. In this case, I chose Y. So what I need to do is for each expression node that we have here, I need to take the non-stretchy weight value, which is this one right here, in this connection, and multiply it by the scale that this guy is having. So when I do that, if the scale is 100%, this value is going to come exactly to the same value that it had before, which is 1 in this case. But when this object is scaling either up or down, then we're going to be scaling also the length at which its joint is positioned. So I'm going to show you how that's going to work. Let's add a multiply node. So we're going to take, we know based on our formula that we worked on the other day, that the non-stretchy weight is variable C. Okay, so let's take the C connection and plug it into our multiply. Actually, let me undo that. Well, let's go first into setup mode, just to be sure. We unplug this, we plug the Y scale, and then we plug that as a new C value. Okay? So if I get out of setup mode, well, right now I don't see any difference because I did the joint at the bottom of the spine. So let's do the one at the top, for example. I don't need to be in setup mode actually to do this. Let's bring this guy all the way over here. We'll see where to place him later, but for now, I'm just going to leave it there. And let's create another multiply node. Let's bring it close to our last joint. And let's bring input C multiplied by the scale. And that's our new C value. And the joint went all the way to the top of the torso. So we just need to do that for each joint, each expression that we have over here. So I'll do one more, and then if you prefer, I'm going to pause the video because, well, you don't need to see it done every time. So again, take input C. I'm just going to unplug it, plug it over here, multiply by the scale, and plug the new C value. And our next joint moves into place. So I'm going to keep going with the rest of the expression nodes, and I'm going to show you the final result once I'm done. Okay, I'm done. And this is what you'll see. I've got my expressions over here. I'm taking also the liberty of collapsing the nodes so that I have a little bit less stuff on screen. And these are the multiplied nodes that I added. And as you can see, each one of these is going to the controls scale channel and multiplying it by the non-stretchy weight value. And now the rig is properly scaled, and I can scale it up, scale it down, and the joints keep their respective positions properly. So we've got that working, and I think pretty much our work with the torso is done. There's just one more feature that I want to add to it, and we're gonna do that in the next video. Okay, the last thing I want to do to our torso here is add a biasing system, and I'm going to show you what that is. Let's take this control and rotate it like so. Okay, so we get this pose over here. Well, there's one thing we haven't revised so far, and it's our falloffs over here. By now, if you remember, the idea behind using these falloffs was that we would not have to weight manually the curve, which we ended up doing anyway because we have to normalize the deformers to solve some of the issues we were having. So the falloffs, you would say right now they're pretty much useless. I could get rid of them. Well, yeah, but they actually do something that is kind of cool, and is I can use them still to be able to affect how that curvature is distributed over the spine. So as you can see, I can bias the curvature of the torso towards either the top or the end of the torso using the range control on the falloff. So that's what I'm going to do. I'm going to build a biasing system that will allow us to manipulate the falloffs so that we can fine-tune how the curvature is distributed along the torso. So let's do that. Let's I'm going to leave this guy rotated for now. And what I'm going to do is I'm going to look for our falloffs over here in the schematic. They're there already. And I'm going to add their range channels so that we can actually use them. Let's make a little bit of space over here for them. There you go. And let's select both and say add a channel range. Sorry, it's out of view, but there they are. There's the range channels for each falloff, okay? And now we're gonna rig them so that we can have a biasing system that drives both falloffs. What I want to see is when one of the falloffs shortens in range, the other one gets longer. So that's going to balance both of them. So we're going to use a math add node to be sort of like our driver. We're going to call it utility center. Let's call it spine BS control. And obviously, again, we'll expose this at some point somewhere in the rig. So what we're going to do, let's add another add. We're going to connect first the curve length value that we have over here coming out of the curve probe. Okay? So if I plug this directly onto the falloffs range, they're going to have that length exactly. But we need to take into account that one of them has to shorten itself while the other one is getting longer. So what I need to do is take our driver value and multiply it by -1 to get the inverse movement on the other falloff. So we're going to plug this guy and multiply it by -1. Okay, so now that I have that, I can come in and plug this guy over here, and we're going to take another add node, and we're going to connect this value directly. So this is for one to go shorter, this one will go longer, and we're going to add also the curve length to it. And now one is going to go to one falloffs range. Let's pick this guy. It's going to go to this range over here. We have to check what's going on over there. Modo complained about the dependency loop, and this one would go to the other one. So let's see what's going on. The reason is I wired these values directly to the curve probe, which is dynamically changing, and I should have not done that. What I need is the length. It's just the original length of the curve. So let's try that again with this value instead. And let's wire the range up. Now we have no problems. Okay, so that's great. So let's see what's going on over here. If I select one of my falloffs, I can see that the length of the range is now modified. And if I play with my math node and I start increasing this value, you can see the distribution change. If I bring it to negative values, I can also bias it towards the bottom, which at some point will break the torso. But this will allow the animator to fine-tune the rotations on the torso if he needs to. Okay, so let's leave it at 0 for now. So this is our biasing system for the spine. And with this, I think we're pretty much done. Let's just see if we need to wire our scale also into this system. So the torso should keep that shape that it has right now. Yeah. Looks like it's working fine. So no problem there. And this pretty much completes our torso system for the character. We're going to start to reorganize our rig in the forthcoming videos. As you can see, we're starting to get near the end of completeness for our character. We still have to do the neck and head, of course, and we're going to take care of that. But before proceeding, we might take care of reorganizing our rig elements over here. So see you in the next chapter.